Picture the end of September 1937. The heads of Italy's national airline, Alitalia, went before their shareholders with a bold announcement. Their new top priority is opening a regular route to South America. From a technical standpoint, this was a serious challenge. At the time, the company's fleet consisted mostly of wooden, three-engine aircraft. It was clear that crossing the ocean would require large, all-metal machines powered by 4 powerful engines. Why 4 specifically? Dropping the third engine on the nose came with a ton of advantages. It eliminated severe vibrations in the fuselage, dramatically improved the pilot's forward visibility, allowed for a more spacious cockpit, and kept exhaust fumes from blasting straight onto the windshield. On top of that, heated debates broke out within the company over what kind of aircraft to build, a conventional land plane or a seaplane. The idea of flying boats looked very promising back then, since global heavyweights like Britain's Short, America's Boeing, France's Leiticoeur, and Germany's Dornier and Blohm-Voss were already well established in that space. Ultimately, the company set an ambitious goal to complete the first experimental transatlantic flight by the following year. Right after this presentation, the engineers got to work. They drafted detailed blueprints for what would become a massive, all-metal, 4-engine giant. This was the CANT Z.511, designed by the talented engineer Filippo Zapata. Once completed, it would become the largest float-equipped seaplane ever built. Up front was a spacious cockpit where the 2 pilots sat side by side, and right behind them were the workstations for the flight engineer and the radio operator. Further back, the fuselage split into 2 levels. The lower deck, about 3.3 feet tall and over 49 feet long, was basically a massive cargo hold. The upper deck was a luxurious passenger cabin seating 48 people, divided into 4 cozy compartments of 12 seats each. For passenger comfort, the aircraft featured 2 restrooms, a small galley, and a storage room. That said, this tightly packed layout turned out to be too heavy for long transoceanic flights, so it had to be redesigned. The scale of this aircraft was unlike anything Italian aviation had seen before. Right in the middle of a flight, crew members could climb down into the cargo hold and from there crawl through narrow tunnels on their hands and knees to reach the interior of the wing, where they could check on the engines and remote fuel tanks. And when the plane was rocking on the waves while moored, the crew could exit through side doors and climb down built-in ladders onto the floats. These floats stretched an astonishing 57.4 feet in length and were tall enough for a person to stand upright on them. But there was one major flaw. The aircraft was supposed to be powered by cutting-edge Alfa Romeo 135 engines. However, Italy's engine manufacturing lagged far behind its designers' ambitions. These engines were produced in very limited numbers, roughly 150 units by 1944, and none were ever fitted to an operational aircraft. The engineers waited years for engines they had expected to receive starting in 1937. But the Alfa Romeo 135 was plagued by reliability problems throughout its life. The debates over how best to cross the Atlantic were being put to the test with actual record-setting flights. In late December 1937, the famous test pilot Mario Stoppani took the controls of a CANT Z.506B seaplane and set a world distance record for seaplanes. He covered 4,362 miles, flying from Cadiz, Spain, all the way to the Brazilian city of Caravelas. But the land plane advocates weren't sitting idle either. By late January 1938, 3 SM-79T aircraft under the command of Attilio Biseo, Bruno Mussolini, and Antonio Moscatelli took off from Guidonia bound for Rio de Janeiro. 2 of the 3 successfully reached their destination. Even the president of Alitalia, engineer Umberto Klinger, got in on the action himself. Together with Captain Carlo Tonini, he completed a long flight aboard a CANT Z.506 seaplane from the Italian city of Cagliari to Buenos Aires in March 1938. These flights demonstrated that Italian aviation was catching up with the transatlantic capabilities that airlines in other countries were already putting into regular service. After lengthy debates and competing demonstrations, practicality won out. The Italian airline established a special experimental division for transatlantic flights, headed by the renowned pilot Attilio Biseo. This division would later grow into an entirely new company called LATI. In the summer of 1938, at a key meeting chaired by Attilio Biseo, a pivotal decision was made. The new routes would use conventional land planes rather than seaplanes, as had been done before. It wasn't an easy choice, but it turned out to be far more practical, both technically and commercially. Amid all these developments, in the fall, the airline's leadership officially announced the start of construction on 3 CANT Z.509 aircraft, along with the beginning of work on the CANT Z.511. This ambitious prototype, still in the design phase, was shown to Benito Mussolini during his visit to the aircraft factory in Monfalcone. The contract for building this machine was signed in October 1938, and the giant was expected to make its first flight just 1 year later. Italy's aviation leadership understood that even if the development of the CANT Z511A variant, where the letter A stood for the Italian word Atlantico, meaning Atlantic, ended in failure, the project would still represent an enormous technological leap forward. So the program received substantial state funding. They even priced out a full production run of 6 aircraft. As design work continued, the seaplane's final appearance changed somewhat. Engineers slightly reduced its length and height, adjusted the spacing between the massive floats, and enlarged the tail assembly for better handling in flight. The most noticeable change was the redesigned nose section. It was given a more conventional, stepped shape, even though the original plan called for a perfectly smooth, streamlined profile. That sleek nose design would later show up on the 4-engine land plane, the Z.511. By early 1939, the Civil Aviation Authority approached the government with an important request. They pushed hard for a second prototype to be built as soon as possible. The reasoning was simple. The aircraft was so large that the risk of losing the only prototype during tests was simply too high. To speed things up, the authority even allocated a substantial sum from its own funds. Top leadership quickly approved the initiative, and by spring, the manufacturer had received the order for a second CANT Z511. But a serious problem stood in the way. Italian engines proved unreliable. Because of this, the first aircraft could only be mostly assembled by the end of 1939. As for the second prototype, work on it had to be suspended entirely because the engineers simply didn't know which engines to install. To salvage the situation, Italy attempted to purchase 6 American Wright R2600A engines in late December. American-made engines had a strong reputation for reliability, and the Wright R2600 was expected to deliver its rated 1,600 horsepower consistently. However, the deteriorating international situation made acquisition extremely difficult, and the engine problem remained unresolved while the flight testing schedule slipped by many months. After testing smaller aircraft like the CANT Z.1015 and CANT Z.1018, they decided to install domestic P-12 engines on the giant. These delivered 1,500 horsepower on takeoff and 1,350 horsepower at an altitude of nearly 11,500 feet. This engine was far from perfect either. It had its share of early issues and was notorious for its very short service life, constantly keeping the mechanics busy. But there was no other choice. It was the only available engine capable of lifting an aircraft this size. The empty weight came to over 45,400 pounds, and fully loaded it tipped the scales at nearly 75,000 pounds. Initially, the engines on the CANT Z511 were enclosed under massive, wide cowlings. But during testing, it turned out the engines ran fairly cool and didn't overheat at all. So the engineers came up with a great idea. Replace them with the more compact, streamlined cowlings from the CANT Z1018. The updated cowling had ideal aerodynamics. It featured a completely redesigned air intake and improved exhaust outlets, making the whole setup much more efficient. To validate the design, in the fall of 1940, a scale model of the CANT Z511 was tested in a hydrodynamic tank. When the war against Yugoslavia broke out in April 1941, Italian command faced a serious problem. To protect the one-of-a-kind CANT Z511 seaplane from possible bombing raids on aircraft factories, they had to hide it immediately. The aircraft was ferried from Monfalcone to the safer town of Grado. As the war intensified, the civilian version of this aircraft, the CANT Z511A, no longer had a clear mission. So military engineers and pilots began exploring how this machine could be used at the front. That same year, an experienced torpedo bomber pilot, Captain Giulio Marini, came up with a daring idea. He proposed converting the seaplane into a ship hunter capable of dropping heavy 21-inch torpedoes. At the time, standard Italian 3-engine bombers used significantly smaller 17.7-inch munitions. The larger torpedo had much greater range. This meant the aircraft could attack an enemy fleet from a safe distance, without entering the range of the ship's anti-aircraft guns. Later, another possible mission emerged. Junior Lieutenant Lusardi commanded a CA-148 aircraft. He, along with Major Tito Trisellini and 3 other Italians, was stranded in the port of Jeddah. They had been interned by the Saudi authorities and were desperately looking for a way out. Their plan was to make it to the middle of the Red Sea, where a rescue seaplane would quietly pick them up. On January 9, 1942, the Chief of Staff of the Regia Aeronautica, General Rino Corso Fuggier, endorsed this risky plan. He believed the CANT Z.511 was the only aircraft that could pull off such a complex operation. Only this machine had sufficient range and reliability and could carry a full crew, which made the risks worth taking. However, an unexpected obstacle arose. The seaplane was still at the Vigna di Valle base, where it had been sitting for months, waiting for military trials and engine work to wrap up. Because of this delay, General Giuseppe Casero appealed to higher command to send a different model, the CANT Z.511, on the mission instead. But headquarters flatly refused. That aircraft had far too little range for such a long-distance flight, so the decision was made to wait until the mechanics fully sorted out the CANT Z.511. Time passed, and on February 11, 1942, the General Staff proposed an alternative plan. The military decided to deploy the long-range SM-75 aircraft. It could secretly take off from airfields at Derna or Giallo, covering a distance of 1,286 or 1,212 miles respectively, and quietly evacuate about a dozen people from Jeddah. This covert operation had been approved by Mussolini in late October 1941. In the end, the mission was never carried out. On February 20, 1942, General Giuseppe Casero definitively canceled the plan. The reason was political. Saudi authorities would have certainly viewed such a secret evacuation as a hostile act. The British would have certainly used this diplomatic incident to their strategic advantage, and roughly 900 Italians who were living peacefully or were interned in the country at the time would have instantly become prisoners of war. The CANT 511 seaplane made its first, rather short flight with pilot Mario Stalpani at the controls, alongside the company's chief engineer Guido Di Vari. Also on board was the aircraft's designer, engineer Zapata. The second test flight, however, which included Stalpani and engineer Renato Rovis, gave the entire team some nerve-wracking moments. During takeoff in the direction of the city of Duino, a fierce wind kicked up. Because the control cables had too much give in them, the pilots suddenly realized they couldn't turn the aircraft. The situation was turning critical, and only by masterfully working the outboard engine's throttles did the experienced test pilot manage to swing the giant plane around, just moments before slamming into the hills around the bay. To safely circle back for a landing approach, the aircraft had to make such a wide turn that it actually disappeared beyond the horizon. People watching from shore were terrified, certain they'd just witnessed a crash. After several long, tense minutes, Stalpani pulled it off. But the incident made it clear that the control system needed immediate and thorough overhaul. They had to completely replace the linkages, the entire set of cables, and install rigid metal rods to fix the cable flex issue. These extensive modifications grounded the seaplane for a full 3 months. Fortunately, the subsequent tests went much better. The aircraft was finally stable. It handled well in the air with no anomalies, and all of its flight characteristics matched predictions exactly. By mid-February 1942, preparations for the official flight tests finally began. First, the engineers nailed down the aircraft's empty weight, and just a few days later they completed a successful test liftoff from the water. Full flights resumed in late February and early March. They also checked the machine's ability to take off at a maximum weight of 61,729 pounds, and later at 74,957 pounds. Then, on March 24th, nature put the seaplane through a brutal test. The machine was tested on the water in rough seas. Wave heights reached about 4.9 feet, and gusty winds reached 34 to 40 miles per hour. The aircraft's total weight was still those same 74,957 pounds. As pilot Mario Stoppani ran through these extreme checks, his fellow crew members were amazed that the aircraft could even withstand such punishing wave impacts. The instrument needles were literally bouncing all over the place from the pitching and rolling. Yet the massive floats and all the connecting structures held up brilliantly under these enormous dynamic loads. A bit later, towing trials were conducted near the scenic spot of Punta Stoba. They showed that for even better stability on the water, the best solution would be to widen the floats. In spring 1942, during a long ferry flight from Monfalcone to the Vigna di Valle base, the crew decided to do a rough check on fuel consumption. But after arrival, Stoppani reported serious problems with the left outboard engine. An inspection revealed a dangerous crack had formed inside it. At this point, the seaplane still wasn't fully completed. The section of the fuselage meant for the luxurious passenger cabin remained completely empty. There wasn't even basic soundproofing, and only occasionally, purely for testing purposes, a few experimental seats were temporarily installed inside. Just to save space, the second CANT Z.511 prototype continued to sit disassembled inside the company's workshops right up until the end of June 1942. All summer long, military officials collected information about the project's status and accumulated test data. By August, the first official reports appeared, describing in detail the machine's weight, its actual flight performance, and maximum range. At the same time, the engineers were anxiously waiting for the final test reports from the experimental center. The situation with the P-12 engines was far from encouraging. 3 of them, from the very first production run, had suffered badly from the extreme stress they'd been put through. These engines had been pushed to their limits during rate-of-climb tests, maximum speed runs, and overloaded takeoff tests. It became obvious that before sending the aircraft on any real combat missions, these worn-out engines would have to be completely swapped out. In late August 1942, a bold idea came up for what to do with this machine. The proposal was to use the CANT Z.511 for covert long-range missions. Its primary task would be secretly inserting small teams of special operations units from the Italian Royal Navy. This aircraft was supposed to quietly drop them near strategically vital enemy military bases and industrial facilities. Another intriguing proposal involved a demonstration flight to South America. After the Rio de Janeiro conference in January 1942, most countries on the continent had sided with the United States. Many severed ties with the tripartite pact nations, though Argentina notably did not. It was the only country that still maintained diplomatic ties and a degree of political alignment with Italy. That's why an ambitious plan came together to link Rome and Buenos Aires with a direct air route, making just a single intermediate stop. The best spot for such a layover seemed to be the Bay of Madeira on the island of Sal. The Italians still had their own infrastructure there: qualified personnel, boats, fuel supplies, and radio stations. From that island to Buenos Aires, it was about 4,250 miles. However, there was a risk that Portugal might deny landing and refueling rights on its Cape Verde territory. As a backup, they could stop in Spanish colonial territories in Africa. Options included landing at Rio de Oro or at Cape Blanc, from which Buenos Aires was about 4,660 miles away, or at Villa Cisneros, which would stretch the distance to about 4,970 miles. The actual crossing of the Atlantic was planned at an altitude of roughly 9,800 feet. Then, while flying over Brazilian and Paraguayan territory, the aircraft would climb higher, to 13,100 feet. To keep the mission completely secret until arrival and avoid potential sabotage by enemy agents, the final landing was planned in the Rio de la Plata estuary near the city of Concepcion. The return trip was equally well thought out. The crew planned to ride the powerful Pampero ocean winds, which could gust up to 62 miles per hour. First, the aircraft would cover 100 to 200 miles along the coastline, then climb to high altitude to reach the Brazilian state of Bahia, after which it would descend to 9,800 feet on the way to the equator, once again catching favorable tailwinds. To pull off this ambitious propaganda flight, engineers proposed swapping the standard P-12 engines for the more fuel-efficient Alfa Romeo 135s. This would reduce fuel consumption and allow the heavy seaplane to take off at a maximum weight of about 86,000 pounds. However, in the fall of 1942, General Fernando Bertozzi Olmedo reported that the engine swap just wasn't possible at the time. Had the new engines been installed, the range would have shot up to an incredible 5,700 miles. But reality was different. The seaplane's current weight of 79,300 pounds was the absolute maximum for a safe takeoff. At that mass, with a fuel load of over 27,500 pounds, the aircraft could cover nearly 6,000 miles. Its cruising speed would be 205 miles per hour, using just 60% of engine power. In January 1943, experienced Captain Pilot Armando Ulivi, along with lead engineers Vuolo and Palanca, arrived in Monfalcone. Their main goal was to verify the aircraft's real-world range through actual flight tests. By February, Ulivi officially received his certification to fly aircraft of this class. After that, at the Vigna di Valle Experimental Center, located on the picturesque Lake Bracciano, he took command of the CANT Z.511 seaplane for a series of test flights and fuel consumption checks. Shortly after, in early February, General Eraldo Ilari held an important meeting. The discussion centered on an entirely different mission, a transatlantic flight to New York. The plan called for the aircraft to take off near Bordeaux, France, cross the ocean, and on the return leg, land on the open Atlantic alongside a friendly submarine for refueling. At first, military leadership actually considered dropping 2 small bombs on the city, but they ultimately scaled it back to a massive leaflet drop. This propaganda angle seemed like the best bet, since it closely mirrored a successful flight over Asmara that an SM-75 had carried out in the spring of 1942. Italian command believed the flight would serve as effective propaganda, particularly among Americans of Italian descent. Italian planners calculated that a propaganda leaflet drop, rather than a bombing run, would avoid provoking a strongly negative reaction and might generate sympathy among Italian Americans. Though in practice, any unauthorized military overflight of U.S. territory would have been treated as a hostile act. Still, these plans collided with the harsh reality of the ocean. Landing a heavy seaplane in the open Atlantic alongside a submarine turned out to be far too dangerous and unpredictable. In the end, the CANT Z.511 was dropped from this operation entirely, and the more suitable SM-95 was chosen instead, though this plan too was never carried out. There were other bold proposals for putting this aircraft to use in combat. For instance, plans were drawn up for raids on oil depots along the shores of the Persian Gulf, or surprise strikes against targets in the Black Sea region. On March 16, 1943, Command ordered fuel consumption trials at the Vigna di Valle base. Captain Publio Maghini was assigned to this mission, a veteran of the well-known 1942 Rome to Tokyo flight. The plan was for him and another pilot to take part in a new, even longer and more ambitious mission. But as the Allies gained ground on multiple fronts of World War II, this plan never got off the ground. It didn't even make it past the planning stage. The CANT Z.511 seaplane was still sitting at the Vigna di Valle station when the armistice came in September 1943. To prevent the aircraft from being captured by German forces, the Italians scuttled it. They took pickaxes to the floats and punched them full of holes. The plane slowly sank and settled on the shallow lake bottom right in front of its home base. In June 1944, Allied forces advanced past German defensive lines and took control of the area around Rome. As they retreated, the Germans left massive roadblocks behind them. This forced Allied troops to find alternate routes and ferry their tanks directly across the local lake using large transport boats. And then something absurd happened. One of those boats accidentally ran into the propeller of the sunken CANT Z.511. The impact sent a heavy American Sherman tank tumbling into the water, and it landed right on top of the poor seaplane, crushing what was left of it. After the war ended, authorities decided to clean up the lake bed of all the sunken military wreckage. The bottom near the seaplane base was blasted with powerful demolition charges. First, that same sunken Sherman tank was hauled out of the water, and then the mangled remains of the aircraft were dragged ashore. The second, unfinished prototype met a similar fate. In the fall of 1943, during the German occupation, it was cut apart with blowtorches and destroyed. The aircraft designed by engineer Filippo Zapata never saw operational service. Together with the land-based variant designs like the BZ-305, this experience laid the groundwork for a new post-war design, the BZ-308. Under its skin, the Z.511 packed some clever engineering for its era. The aircraft was a large, float-equipped seaplane, specifically designed for long-range transatlantic flights, both passenger and cargo. It was an all-metal monoplane with 4 powerful engines and a low-mounted wing. The wing had a trapezoidal shape and consisted of 5 main sections, including the center portion with engine mounts and the outer panels. Both the internal framework and the outer skin were made of duralumin, lightweight yet very strong. All movable control surfaces on the wings were also built entirely from metal. One clever touch: maintenance corridors built into the leading edge of the wing. These allowed mechanics to inspect the engines and fuel tanks right in the middle of a flight. The tail section was also duralumin, though some of its movable parts were covered with special aviation fabric to save weight. The elevator's main spar was welded from steel tubing. The metal floats were attached to the fuselage through a complex system of steel struts. Hidden inside these supports were ladders that allowed the crew to move safely between the floats and the maintenance tunnels in the wings. The fuselage itself had a streamlined elliptical cross-section and was built entirely from the same reliable duralumin. At the heart of the machine were the engines, fitted with 3-blade metal propellers, model P1002. They featured an in-flight variable pitch system and maintained constant RPM thanks to an advanced electric control system. Fuel was stored in large tanks hidden in the wings and part of the fuselage. Auxiliary tanks held about 353 gallons of aviation fuel, while the total maximum capacity of the fuel system came to an impressive 4,316 gallons, equivalent to over 26,301 pounds. In the spacious cockpit, the pilots sat side by side. The cockpit featured dual controls and a modern instrument panel for monitoring all flight parameters and engine performance. The aircraft was capable of instrument-only flight and was even equipped with an Italian-made Salmoiraghi autopilot. Right behind the pilot's seats were full workstations for the radio operator and the flight engineer, complete with 2-way radios and precision navigation instruments. The first experimental prototype didn't yet have a passenger cabin, but the designers had carefully planned out the cabin layout. It was meant to be a comfortable space with solid thermal and acoustic insulation. For long transatlantic flights, a spacious layout for just 16 passengers was envisioned. The cabin would be divided into 4 separate compartments with comfortable fold-down sleeping berths. Each berth was supposed to have its own lighting, ventilation system, and even individual heating. For higher capacity flights, seating would increase to 48 passengers. In this denser configuration, passengers were also placed in 4 spacious sections, but with 12 people in each. As for onboard amenities, the engineers designed a galley and a lavatory forward of the main cabin, while another restroom, along with a storage compartment, was located in the tail section. The lower cargo hold had a unique design. It stretched beneath the entire length of the passenger zone, and most importantly, the crew could access it mid-flight. To reach the cargo, crew members had to pass through special tunnels hidden in the leading edge of the wing, and from there carefully climb down into the aircraft's floats.